Hello, this is our AP Physics 1 performance task by Cynthia Gan, Sharita Ravula, and Karina Cabrera. To start off, we need to understand the situation at hand, which is an automobile incident that took place, let's say, at the beginning of the year. Mr. Garcia, a simple car driver, a simple citizen out there, claims to have made a full stop and is blaming our other suspect, Miss Wakefield, another individual, that she did not slow down as she approached the flashing red light. On the other hand, Miss Wakefield, our truck driver, claims to have been braking before the collision and that Garcia did not come to a complete stop. Now, who is lying in this scenario? To figure that out, to solve this case, this conflict, we need to learn a few basic physics concepts. To start off, we need to know what kinematics are, which is the study of objects moving through space, distance, displacement, speed, velocity, and acceleration. Momentum, measure of an object's mass and velocity. And to know how to find momentum is just found as mass multiplied by velocity, as it is seen on the top right corner. Conservation of momentum states that momentum is conserved during collision of any sort, including an elastic collision. This formula can be seen on the bottom right corner. And force. The cause of an object's motion can include normal, gravitational, frictional, and applied forces, which can be seen on the top left corner. Force equals mass of an object times its acceleration. Now, we get to the calculations, which show us that Mr. Garcia is at fault. Well, makes us believe he is at fault. Now, why do we believe this? Well, to start off, we need to find the coefficients of friction. We start off with the constant velocity, which normal force equals 0. Fa minus Ff equals 0, which is equivalent to the normal force, and all of this is for the car tire. Now we move on to 100 minus Ff, which is equals 0. Force of friction is equivalent to N normal, and Nmg is equal to N 130. 130 N is equal to 100, which is the mu of the car tire, which is equivalent to 100 over 130. Now, we know that the N of the truck tire is 70% of the car tire. So this leads us to the N truck tire to being equivalent to 100 over 130 multiplied by 0.7, which then leads us to the N car is equivalent to 0.77, while the N tire is equal to 0.54.
We can calculate the forces of friction for both the car and truck by taking the mu of each that we calculated in the previous slide and multiply that with the weights of each respective vehicle. For the car, the value with mu that we got was 0.692307, and we multiplied that with the weight of the car, which happens to be 13,600 newtons. This results in 10,461.5385. For the truck, the value with mu that we got was 0.538461538, and we multiplied that with the weight of the truck, which happens to be 69,700 newtons. And the result of that is 37,530.7692. To calculate the masses of the vehicles, you already know that the weights for each respective vehicle are 13,600 and 69,700 newtons. However, these are a result of multiplying the masses of each with the force of gravity, which is 9.8 meters per second. So when you divide each of the weights by 9.8, you get the mass of the car to be 1,387.7551 kilograms, and the mass of the truck to be 7,112.2449 kilograms. To calculate the acceleration from the force of friction, we utilize the equation of F equals ma, We previously calculated that the forces of friction for the car and truck were 10,461.5385 and 37,530.7692 respectively. And we also found that the masses of the car and truck were 1,387.7751 or 7,551 and 7,112.2449 kilograms respectively as well. However, while using the equation of F equals ma, since we already have the forces and masses, we just need to find the acceleration of each vehicle, and we can do so by dividing each respective numbers with each other, which results in the acceleration of the car from the force of friction being 7.53846,158 meters per second squared, and the acceleration of the truck from the force of friction being 5.27692307 meters per second squared. Additionally, to calculate the velocity of the vehicles right after the collision, we utilize the kinematic equation of v squared equals the initial velocity squared, plus 2 times the acceleration times x. So the velocity of the car can be calculated by substituting in the negative values of the vehicle's accelerations. We multiply this by the values of displacement that we were provided with, which for the car was 8.2 meters and the truck was 11 meters. This results in the initial velocity of the car being 11.11893744 meters per second, and that of the truck being 10.77461403 meters per second.
Next, using the velocities of both vehicles right after the collision, we can determine their velocities just before the collision using the law of conservation of momentum. Since the vehicles collided at a 90-degree angle, we can isolate the truck as the only object moving initially in the horizontal direction. As such, according to the conservation of momentum, the truck's initial momentum is equal to the sum of the car and the truck's horizontal components of momentum after the collision. This means that in the equation itself, the only change we make is that we multiply the momentum by the cosine of the angle that they traveled in after the collision. Using this, it gives us the truck's initial velocity to be 12.51 meters per second just before the collision. Similarly for the car, since we know that it was the only object moving in the vertical direction before the collision, we can set its initial momentum equal to the car and the truck's vertical components of momentum after the collision. Doing the same process with this time replacing the cosine of the angle with sine of the angle to get the vertical component, it gives that the car's velocity before the collision was 12.78 meters per second. Finally, we can determine who is lying in this case. We believe that Mr. Garcia is mainly at fault because he claimed to have made a full stop, but according to the calculations, it would have been physically impossible for him to have done that and still traveled the same distance after colliding with Ms. Wakefield. This is because his vehicle's specifications say that the maximum acceleration is 3 meters per second squared. And using this value in the kinematic equation, final velocity squared equals initial velocity squared plus 2 times acceleration times displacement, we see that this is untrue. Because using the value of the initial velocity as 0, because he made a full stop, the acceleration is 3 as specified by the car company, and the displacement as 13, which was the distance of the collision spot from the red light, it gave that the final velocity was 8.8 meters per second. This means that 8.8 was the maximum speed that he could have been traveling before he collided with Ms. Wakefield. However, our calculations show that he was actually going 12.78 meters per second, meaning that Mr. Garcia must have been lying. However, Ms. Wakefield was also lying, so she is not completely innocent. She claimed to have been going 6.7 meters per second, but the calculations show that she was actually going at 12.78 meters per second.